Firstly, what is a linear sequence? A linear sequence is a sequence of numbers where the terms increase or decrease by the same amount each time. Here are some examples of linear sequences. The first sequence increases by 2 each time. The second sequence decreases by 4 each time. In the third sequence, you add 10 each time to get to the next term. The amount that is added each time, or subtracted each time, is called the common difference. In exam questions, you're often asked to find the nth term of a sequence. But what does the nth term mean? Well, suppose we have the sequence 2, 7, 12, 17. You can probably work out that to get to each term, we add 5 each time. So if someone asks you to find the 5th term in the sequence, you could probably work that out. The 2 is the first term in the sequence, the 7 the second, 12 is the third term, 17 is the 4th term. So to get the 5th term, you would add 5, giving you 22. But what if you were asked to find a higher term, say the 20th term in the sequence? It would take quite a bit of time to keep adding 5 to get to the 20th term. So can we find a quicker way of doing this? Luckily there is. To find terms in this sequence, we use the formula 5n minus 3. Here n represents the number of the term in the sequence we want to find. Say we want the first term. We already know this, but let's check the formula works. So we would do 5 times 1, because we want the first term, minus 3, which equals 5 minus 3, which equals 2. And indeed, 2 is the first term in the sequence. How about the third term? If we want the third term, we would do 5 times 3, as we want the third term, minus 3, which would be 5 times 3 is 15, minus 3 equals 12, which is again correct. We can see that here. So what about the 20th term? Well, this is where the formula becomes really helpful, because instead of adding 5 each time to find the 20th term, we can simply put 20 in this formula to find out what the term will be. So the 20th term, we do 5 times 20 minus 3. 5 times 20 is 100, minus 3, which equals 97. So we've saved ourselves a lot of work because we can find the 20th term straight away. This formula makes it really easy to find, say, the 100th term straight away, or even the 2000th term. It's this formula that's called the nth term of the sequence. So when exam questions ask you to find the nth term of a sequence, what they're looking for is for you to find a formula like this that will generate all the terms in the sequence. How do we find the nth term of a linear sequence? Say we have the sequence 5, 8, 11, 14, 17. First, let's check that this is indeed a linear sequence. If we calculate the difference between the terms, we can see that to get from 5 to 8, you plus 3. To get from 8 to 11, you plus 3. To get from 11 to 14, you plus 3. Likewise, to get from 14 to 17, you plus 3. So we can see that this is a linear sequence, as the difference between the terms is the same. Now let's see how to find the nth term of this sequence. Here's a step-by-step guide to help us. So step number 1 is find the common difference. So we've already done that. We've found that the common difference, so the difference between each of the terms, is 3. The next step tells us to multiply this common difference by n. So we have 3 times n, which is 3n. Now we're going to write this in a final answer box. So this is where we're going to put our final answer once we've worked it out. So in here we write 3n. So this is the beginning of our final answer, but there's something missing that we're going to continue to work out. Step number 3 is we make a table. The table we make looks like this. We have 3 rows. In this corner we write n. Next to it we write 1, 2, 3 and 4. Then for the middle row, here we write the part of the final answer we already have, so 3n, so the common difference times n. Then for the bottom row, here we write term. Now let's fill in the table. In this row, we need to calculate 3n for all of these n values. So here n equals 1, so 3 times 1 is 3. Here when n equals 2, we have 3 times 2, which is 6. Here n equals 3, 3 times 3 is 9. And here, n equals 4, and 3 times 4 is 12. In the bottom row, we write the terms of the sequence corresponding to the n values. So when n equals 1, the term of the sequence is 5. When n equals 2, the term in the sequence is 8. When n equals 3, the term in the sequence is 11. When n equals 4, the term in the sequence is 14. So we've done number 3. Step number 4 is we work out what we need to add or subtract to go from the second row to the third row. So to get from 3 to 5, we plus 2. To get from 6 to 8, we plus 2. To get from 9 to 11, we plus 2. And to get from 12 to 14, we plus 2 also. So you can see to get from the second row to the third row, we plus 2. We then copy this over here in our final answer box. So we put plus 2 here. And there we go, that's our final answer. So the nth term of this sequence is 3n plus 2. Now, once you've got an answer, it's a really good idea to check that your final answer makes sense. As this is a formula that gives us all the terms in the sequence, if we substitute in n equals 1, 2, 3, 4 and 5, we should get these numbers here. So let's check this makes sense using a couple of n values we know the answer to. So if we try substituting in n equals 1, if this is the correct formula, we know that this should give us 5. So substituting in n equals 1, we get 3 times 1 plus 2, which equals 3 plus 2, which equals 5, which is what we wanted. Now let's try substituting in n equals 4. So n equals 4 should give us the fourth term here, 14. So substituting that in here, 3 times 4 plus 2 equals 12 plus 2, which equals 14, which is the term that we wanted. So checking your final answer with a couple of n values that you know the term for is a really good way to make sure you haven't made any mistakes. Let's try another example. Now let's say you're given the sequence that begins with 20, 18, 16, 14. Let's try and find the nth term for this sequence. So to begin, we start with step 1, find the common difference. So here you can see to get from term 1 to term 2, you subtract 2. Likewise for term 2 and 3, you subtract 2, and to get from term 3 to 4, you subtract 2. So the common difference is minus 2. The second step is you multiply it by n. So this would be minus 2n. And we know that this is going to form the first part of our final answer. The third step is we make a table. So let's move that down here. So remember, we begin by drawing out our table. On the top we write n, and we write 1, 2, 3, 4. Then we write term on the final row, and we copy out the terms that we have of our sequence. So the first term is 20, the second term is 18, third term is 16, and the fourth term is 14. Then we write our common difference multiplied by n in this box here. So we've already worked that out, minus 2n we can write here. Then we finish this row by calculating minus 2n using these n values. So here we have n equals 1, so minus 2n, minus 2 times 1 is going to be minus 2. Minus 2 times 2 is going to be minus 4. Here n is 3, so minus 2 times 3, minus 6. And then here n is 4, so minus 2 times 4 is minus 8. Step number 4 is we work out what we need to add or subtract to get from the second row to the third row. If we look at the first terms here, to get from minus 2 to 20, we need to add 22. Likewise, to get from minus 4 to 18, we need to add 22. Again here, minus 6 to 16, add 22. And minus 8 to 14, as you probably guessed, you add 22. So to get from the second row to the final row, you add 22. We then write this in our final answer box. And there you go, that's the final answer. That's the nth term for this sequence. So again, remember, as soon as you've got your final answer, you should check it with the first few terms of the sequence. So when n is 1, we should get the first term being 20. So let's check that. So substituting in n equals 1 in here, minus 2 times 1 is minus 2, plus 22 gets you the 20, so that's correct. We can check it with n equals 2 as well, so we should get 18, let's check. Minus 2 times 2 is minus 4, minus 4 plus 22, that's the same as 22 minus 4, that does give you 18. So we can be confident that we've got the correct final answer. Let's try one last example. This is a good time to pause the video if you want to try this first yourself. Otherwise you can watch me go through it now. So we need to find the nth term of this sequence. So step number 1, we find the common difference. So here we can see to get from 10 to 16, you add 6. And again here, to get from 16 to 22, add 6. And here to get from the third term to the fourth term, 22 to 28, we add 6 again. So the common difference is 6. Step number 2, we multiply it by n. So we're going to write 6n down here. And we know that this is going to form the first part of our final answer. Step number 3 is we make a table. So we draw out our table. We write on the top row n, and then next to it 1, 2, 3, 4. You could just write 1 to 3 if you like, or you could do more, you could write 1 to 5, but I think 1 to 4 makes it clearer. So at the bottom we write term, and we write in the terms we're given. So the first term is 10, second term is 16, third term is 22, and the fourth term is 28. In the middle row, we write our common difference multiplied by n, so what we already have as part of our final answer. So we write 6n here, and then we fill in this row by working out 6n. So we do 6 times 1 is 6, 6 times 2, because here n is 2, so that's going to be 12, 6 times 3 is 18, 6 times 4 is 24. And then we go to step 4, work out what to add or subtract when going from the second row to the third row. So here we're adding 4, and you can see all the way along this row we're adding 4 to get from the second row to the third row. Plus 4 here too, and plus 4 to get from 24 to 28. So to get from the second row to the third row, we add 4. So we then finish our final answer by writing in plus 4. So there we go, that's the nth term of this sequence. Again, let's check. So when we substitute in n equals 1, we should get 10. Let's check. 6 times 1 is 6, plus 4 gives us 10. So that's looking good. Let's try again with n equals 2. 6 times 2 is 12, plus 4 is 16, which is what we had here. So that's all looking good. So we can be happy that we've got the correct nth term. So now you know what a linear sequence is, what the nth term means, and you're able to calculate the nth term of a linear sequence. I'd really recommend memorising the 4 steps in finding the nth term of a linear sequence. It might be worth writing out a card like this yourself and sticking it somewhere around your house to help you remember it.